Alright, we are looking at the third page, questions 4, 5, and 6 today of the August 2020 Khomas Region Mathematics Higher Level Paper 1. Okay, we've already looked at questions 1, question 2, and 3, and now we're doing this page, question 4, 5, and 6. I initially thought I'd just do single question per video, but in this case it's only 1 mark for a single question, so I thought I'd rather do a whole page. Okay, describe the locus of the tip of a minute hand on a clock, and the hand is 5 centimeters long. Okay, so this is, for 1 mark you could probably just say a circle as it moves, but let's just see what we mean here. So the minute hand, they say, is something like that, and now the tip of the minute hand, as the clock goes, how does that move? It moves in a circle like this, right? So it makes a circle as it moves. So we can say it's a circle, and the radius of the circle will be the length of the hand of the clock, so that'll be 5 centimeters, right? The circle of radius 5 centimeters. I think circle might be enough, but since they gave us the distance, it's probably good to add that in. Circle of radius 5. Great. Question 5. Okay, given that x goes from -4 to 2 inclusive and y from -6 to 3, all of it inclusive as well, find the largest possible value of x minus y. Okay, so let's have a look at this. So if we want the largest possible value, largest possible difference, we have to take the biggest distance between these two, right? So let's just say if we had something like 5 minus 2, that's bigger than like 3 minus 2, right? So we want to make the first number as big as possible. Let's actually do this, just to show. Let's say we start with 2 minus 2. We see that's 0. Now if we want to improve this or make it larger, we can make the first number larger. So 3 minus 2, that's 1. Yes, that's larger. If we say 1 minus 2, so we make it smaller the first number, we get -1. So that's smaller. We don't want that. On the other hand, what happens if we change the other side? So if we change the right hand side to something smaller, we get 1. That's bigger than 0. That's good. If we change the right hand side to something bigger, we get -1. That's again smaller. So we see we want the left hand side, so left hand side, we should increase that side, and the right hand side, that one we want to decrease. So that'll give us the maximum distance between the two. So biggest possible value for x, which is 2, minus, and the smallest possible value for y. Smallest possible value for y is -6. So 2 minus -6, that becomes 2 plus 6, and that is 8. Alright. Smallest possible value of x times y. Okay, this is an interesting one. So if we were just working with positive numbers, we would just take the smallest thing times the smallest thing, right? And that'll give us the smallest thing. But since we have negative numbers involved here as well, if we just take the smallest of both, so let's say -4 times -6, what happens then? Then we get negative times negative is a positive 24. So that's a pretty large number. Now, what happens if we just take 0 times 0? So 0 times 0, that gives us 0. That's quite small. But what we can also do is we can take the smallest negative, or the smallest of one and the largest of the other one, and see what happens then. And then we can compare that to the largest of the first one and the smallest of the other one. So let's check. -4, we do the circles first. So -4 times 3, that gives us -12. Smallest so far. Okay. Let's try the other one. So we've got a 2 times a -6. That also gives us -12. Alright, so we see our smallest value that we can get is -12. So a very negative number and a very positive number. Well, the most negative and the most positive that we can find, and we try both cases. Okay, -12. The smallest possible value of x squared. Okay, so again, let's say we take the smallest number for x and we square that. So -4 squared. The other negatives come into play again. So a negative times a negative will become a positive, so we'll get 16. Okay. If we take the largest positive number, 2 squared, that's obviously a silly idea to take the biggest number and square it, but 2 squared will be 4. So that's smaller than 16, but in this case it looks like the smaller the number without regard for the sign. That'll be our answer. So that'll be 0. What happens if we square 0? And we get 0. That'll be the smallest. Because anything else we square, let's say negative 0.01, if we square that, it'll still be bigger than 0, right? It'll be 0.00001. But it'll be positive, which is bigger than 0. So 0 squared will give us 0, and that'll be our final answer. Okay, last question for this video, a probability question. We get told that the probability that the school bus is late is 9/10. Now, if the school bus is late, then the probability that Seth travels on the bus is 15 out of 16. But if the school bus is on time, then the probability that Seth travels on the bus is 3/4. So now we have to find the probability that Seth travels on the bus. So this is regardless of whether the bus is on time or late. What is the probability on any given day that Seth travels on the bus? Okay, so there are two ways you can travel on the bus, either if the bus is late or if the bus is on time. So let's draw a tree diagram for this one, just to show what's happening. So the bus can be late or the bus can be not late. Then, if the bus is late, then Seth can travel on the bus or not travel on the bus. If the bus is not late, he can also travel on the bus or not travel on the bus. Now let's see what we get here. So, but the bus is late, the probability of that is 9 out of 10, which means the probability that it's not late is then 1 out of 10, because together this must make up a total of 1. If the bus is late, the probability that Seth travels on the bus is 15 out of 16. So that means the probability that it doesn't travel on the bus if it's late is 1 out of 16. And again at the bottom here, if the bus is not late, or on time rather, the probability that Seth travels on the bus then is 3/4. So the probability that he doesn't travel on it is then 1/4. So what we want to find is we want to add up all the values on the right here that includes him traveling on the bus. Okay, so this one he does travel, and this one he does travel. Here he does not travel, and here he does not travel. Okay, so what will this value be? Well, that's just multiplying along the branches. So 9 over 10 times 9 over 10 times 15 over 16. And that gives us, what do we do here? Let's just simplify a little bit, 3 and 2. That gives us 27 over 32. Okay, and this one, 1 over 10 times 3 over 4. So 1 over 10 multiplied by 3 over 4. That gives us 1 times 3 is 3, over 10 times 4 is 40. So now we have to add these two together. So that, common denominator for 40 and 32, that should be 160. Alright, so 32 times 5 is 160, so 27 times 5 is 135. And 40 times 4 is 160, so 3 times 4 is 12. And we can get from there to 147 over 160. So that, I believe, is the simplest form for this. So that'll be our final answer. Or we could write it as a decimal. That should be, I think I've already typed that in here. Let's just make sure. 147 divided by 160, that's 0.9875. 0.98, is it 0.91875? Okay, 0.91875, and they didn't tell us to what degree of accuracy we should round this off. So if we can leave it in a fraction, and I would suggest that, but if not, then we have to round this off to, what did they say in the beginning here? 3 significant figures. Okay. So 3 significant figures, 0 doesn't count as a significant figure, so that'll become 0.918. So we have to round it off to here, so the 7 will turn this into a 9. So 0.919. Okay, so that is the probability. And then I'll see you again shortly for the next page, question 7, it looks like. And we might even do a bit more. Okay, see you soon.